واضح.
حد عنده سؤال شباب قبل لا نبدأ؟ طيب okay. Today we are going to finish the magnetic circuit subject, and we will start on Wednesday the transformer. I posted the homework to the Blackboard, and the submission will be, of course, next week. So you have more than 1 week to finish the homework, and the homework will cover the magnetic circuit and also transformers, which we will finish inshallah also next week. So if you remember last time we discussed, actually we solved examples yesterday on magnetic circuits, how to represent magnetic circuits, how to analyze magnetic circuits. Today we're going to talk about little few things about magnetic circuits, about some losses and also some practical considerations. One of the practical considerations is the BH, what we call BH curve. And if you remember this equation, which is B equal mu H, that we used before. It's relating basically the density to the intensity H through mu. So basically, if you divide B by H, this will give you mu. And this equation is a linear equation based on our assumption that the value of mu is constant. You remember when I mentioned the mu r, for example, I said if mu r for a certain material is 1000, it means that the value of or the capability of the material to conduct magnetic flux will be more by 1000, or the reluctance is less by 1000, etc. That's true, but in practice, this value of a mu is actually changing based on the value of B and H. It's not constant. In other words, the relation between B and H is not linear, meaning that if you increase H, B will increase, but at certain region, the rate of increase will not be the same. So nonlinear relation. So nonlinear relation, it means that the value of a mu is not constant. Or if the value of a mu is not constant, it means that the relation between B and H is nonlinear. And why we are having this? Well, this is in practice. And even the resistance of the wire, for example, it has to do with the temperature. So there are variables actually can affect the values such that the value of the resistor, for example, is not constant. But usually you assume it's a constant in wires, for example. But in reality, if you have high temperature, the resistivity of the material might be different than if you have cold temperature, right? So in magnetic circuits or magnetic cores, we have also similar phenomena, but it's between B and H. So if you see the figure here, this is basically a linear region, meaning that the relation between B and H is linear. Hence, if you divide B by H, mu will be also constant. But for high values, the relation will start to be nonlinear, which is this near region. So now the assumption that mu is constant all the time is not valid anymore. There is a third region, which is a very important region or concept, which is called the saturation. What is the meaning of saturation in Arabic? بالعربي ايش معنى saturation?
تشبع.
تشبع, yes, that's correct. So in this region, what we are saying here is that if we reach this region, if the magnetic core reaches this region, it means that the material will be saturated with the magnetic flux. متشبع, يعني خلاص ما في مجال اصلا انه يكون في magnetic flux more. مثل لما يكون مثلا الwater pipe is saturated, يعني معناها full, مويه ماليه.
دكتور وش المتشبع بيكون؟ الفلكس؟
Yes, magnetic field and flux. Yes. So even if you keep increasing H, okay, even if you keep increasing H, the increase in B will be very minimum, as you can see here, right? It's almost constant, meaning that if you keep increasing H, B will be constant, meaning that, you remember B, it's the magnetic field in unit area. You remember the definition? So meaning that the magnetic field in unit area will be constant, will be the same. هذا معنى التشبع، صح ولا لا؟ You cannot add more magnetic flux to the area. So yes, at certain region, even if you keep increasing H, B will not increase, flux will not increase. So that's it. متشبع. So based on what we have this saturation region, based on what we can draw this relation. Well, different materials, they have different characteristics. Some materials, they have this wide saturation region. Some materials, they have narrow saturation region. But in conclusion, this relation between B and H is nonlinear. This is the main conclusion we take here. It's nonlinear. If it is linear, it will be just straight line. Okay? Any question regarding this?
دكتور ممكن تقول لنا ايش يمثل البي ولا اتش؟
B is the magnetic flux density, which is basically, it's like, if you remember the cross-sectional area of the magnetic core, it represents how many dots of magnetic fluxes you have in here in this area. You have small number of magnetic fluxes, you will be small because